Today we're going to look at direct proportion, but we're going to create formulae from some simple sentences. I just want to recap though, what do we mean by direct proportion? Well, it means two quantities, if we plot a graph, then we get a straight line. As one doubles, the other doubles, or we say as one increases, the other increases by the same percentage. That's really important. And we looked at a recipe, so using making pancakes using flour, and there we got a straight line for desserts, beans of flour against pancakes. We looked at paint and the price of paint, and we sort of, we were told that they were directly proportional, but we saw then for circles that the area is not directly proportional to the radius. Okay, just to remind you, we got this kind of graph. But if I plotted the area against the radius squared, I did get a directly proportional relationship. So it's, you need to think carefully about this. And we said that basically if two things are directly proportional, then we can write this. Y is directly proportional to x, and then you get this equation. But if, for example, y was directly proportional to x squared, then it would become a squared here. So just be aware of that. And I spent quite a long time going through that, trying to give you an understanding from it, because from now on, we're basically going to jump straight into this formula. Now just remember, this is just a form of y equals mx plus c. It's just that c is 0 because it goes through the origin. And we can change it to say x cubed if it's x cubed that is directly proportional, and then you'd still get a straight line when you plot against x cubed. It's a bit of a different idea. It's probably the hardest bit to get your head around, really, because we're normally used to plotting against x, but the point is that if they are directly proportional and we plot against x cubed, then we get a straight line. We're not really interested in what it looks like if I plot it against x. Anyway, let's see an example in action of the sorts of things we can now do using this knowledge. So, P is directly proportional to the square of Q. That means I can write this down straight away. And then I can write down that P is equal to KQ squared. That's always going to be step 1 and step 2. But then it says P is 75 when Q is 5. Express P in terms of Q. Well, I have expressed P in terms of Q, but I've not done it as much as I can, because I've also got this sort of little piece of information here. I can substitute this in for P and Q to find out what K is. So it must be that 75, sorry, this is part A, 75 is equal to K times 5 squared. This is 25. Then I can do 75 divided by 25, and that's going to give me K equals 3. And then my answer is going to be P equals 3 Q squared. And I have expressed P in terms of Q. And once I've done that, I can make predictions or work out values with given one value, because I've managed to get rid of K. So for part B, work out the value of P when Q is equal to 7. All I need to do is substitute in my 7, but it's going to be 7 squared in this case as I get it. And then I'm going to get 147, and I've figured out, I'm not really talking about pancakes or anything now, but it doesn't really matter. The idea is applicable to all these directly proportional problems. Finally, work out the positive value of Q when P is 27. So again, I return to this formula, but this time I'm substituting in for P. So 27 is 3Q squared. Okay, notice I'm reverting, like K is always the same, but Q and P are changing. That's going to mean that Q squared is 9, and I can take the square roots, but it's going to be the positive square roots, and that's going to equal 3. And I've solved my first directly proportional problem. Not too bad. The difficult bit is making sure, I don't want to say remembering this, making sure you understand where this has come from, okay? Really important to understand this bit here, which is why I spent an entire lesson basically talking about it. Okay, let's keep going. We're going to do a very similar example just to get, just to consolidate this, and then we're going to look at one slightly trickier one. So this time y is directly proportional to x cubed. So I can write this down. This is, this is fine. And then that means that y is equal to kx cubed. This k is going to be different than last time. That's all right. I can still use k. Find, and then when x equals 10, y is 250. Find a formula for y in terms of x. So again, I'm going to substitute in my values. Part A, I can write down that 250 equals k times 10 cubed. That's going to be 1,000. I'm going to divide through by 1,000. I'm going to get k equals 0.25. And my final answer is then going to be y equals 0.25 x cubed. I have managed to get a formula for y in terms of x. Finally, calculate the value of x when y is 54. Very common sort of question. This is how it's going to be, except for a few little other ways it might be tested. We're going to get that 54 equals 0.25 x cubed. I can divide through by 0.25, which is the same as timesing by 4, which is going to give me 216 equals x cubed. X is the cube root of 216. Now this is nice, 216 is actually a cube number, and the answer is going to be 6. Done. Okay, so this is a sort of question that I want you to be able to solve, showing you working in this format. Okay, last question, trickiest one. Y is directly proportional to the cube of x. Y is directly proportional to x cubed. That means we can write down that y equals kx cubed. Just gonna write that down. I'm not even looked at the question yet. Find the percentage increase in y when x is increased by 20. So I'm just going to change this slightly. I'm going to change this to y old equals kx cubed, with kx old cubed, okay? And then I've got the x new is equal to a 20% increase in x0. How do we do that? Well, we're going to use the idea of multipliers that we've learned about. To increase by 20%, well, we've got 100% to start with. I increase by 20%, so I want to know 120% of my original amounts. 120% as a decimal is just 1.2. So x new is 1.2 times x old. So if I want to work out what y new is, then of course it's going to be kx new cubed, but then I can substitute in for my x new cubed. I can write k 1.2 x 0 cubed, and I can expand this out. I can do k times 1.2 cubed times x 0 cubed. Notice what I've done with the power there. Now we can work out what 1.2 cubed is, and it's actually 1.728 kx cubed 0. But if we look at this, we see that actually this thing here is just our y old. And what we have is that y new is 1.728 times y old. So I've managed to do this calculation. I've got this. This means a 20% increase. What does this mean? Well, if my multiplier is 1.728, that means I've got 172.8%. And so I have a 72.8% increase. That is my answer. Now, I would strongly recommend you show your working like this really carefully. At the end of the day, all I've done is cube 1.2 and then converted it back to a percentage increase. But I think it's important to understand these steps and sort of see how it links together, because that's where the understanding comes from. But yeah, that's how you do it. So these are some questions on direct proportion, and now I want you to practice some yourself.